Okay, so now we're going to carry on with some more proving triangles congruent and introduce this idea called CPCTC. Okay, now the first thing that I want to really emphasize, and this is extremely important, is the idea of what your strategy is, how you go about doing these proofs. The first focus, please, please, please don't put it on the picture. Glance at the picture, see that it's there, it's okay. Don't stare at the picture to give you your pathway to a proof. Use every single piece of the given. That's your pathway to the proof. Second, mark everything you used. So put a little check mark on it, okay? Over time, you don't really have to mark it anymore. But in the beginning, it's important to, because if you're stuck, you just look for something that doesn't have a check mark and you use it. And then once all the given is used, you look for a linear pair situation, reflexive, vertical angles. So let's try this one. And you did this exact question the other day. So it'll be good to see how you handle it. Go ahead. Okay, so we're told that MC bisects HR and that A is a midpoint of HR. And one of the things we talked about was the importance of the specificity of vocabulary. How if it says bisects in the given, you better use bisects in your reasons. If it uses midpoint in the given, you better use midpoint in your reasons. So first up, I wrote that AH is congruent to AR. Now, AH and AR are the two parts of HR, and that is the thing being bisected. So the reason for step 2 is a bisector divides it into two congruent segments. Okay? The word bisect here, the word bisect here. Very, very, very important. They must match. If they don't match, you might say, oh, come on, it looks like a midpoint. That's great. And it may be true, but you don't know it's true until you use what's in the given. And that's what I mean about staring at the picture and letting the picture tell you, oh, it looks like A is a midpoint. I don't care what it looks like. I care what the given says. The given says it bisects. Look, you can have some kid who looks like the most clean-cut kid on the face of the earth. And the kid could be a terrible, horrible kid. Or you could have a kid that you look at and you're like, oh my God, this is just, I can't believe what I'm looking at. And it could be the greatest kid on the face of the earth. In other words, don't judge a book by its cover. Use the given, work the given. Okay, now, so that means I've used bisect, so I don't need to think about that anymore. Now, midpoint. With midpoint, since A is the midpoint, oh, it says of HR, but let's make it A is the midpoint of MC. That means that AM is congruent to AC, and that is because a midpoint divides into two congruent segments. I actually changed this on the other one. I don't know why it didn't change here. Maybe it didn't save. But remember, we're just going to make it the midpoint of MC, okay? So a midpoint divides it into two congruent segments. It says midpoint here. We say midpoint there. Almost sounds like a cheer, like you could have a bunch of your college cheerleaders going, you say midpoint, I say midpoint, yay, midpoint. Or you say bisector, I say bisector, yay, bisector. Something to that effect, okay? So let's mark the diagram. Now I've used up all the given. Now you can look at the picture and look for, rather than look at the total beauty of the picture, rather than saying to yourself, oh my God, this is like Picasso, Rembrandt, Vincent van Gogh. This is just spectacular work. No, no. You're looking for a linear pair, reflexive, or vertical angles. And when you see the letter X, like you see here, the intersecting lines, we're looking vertical angles. So angle 1 is congruent to angle 2 by intersecting lines form congruent vertical angles. Mark it. Great. Okay, step 5. I've got all of that information. I look at it and I say, you know what? That's a pretty good looking picture right there. I've got side, angle, side. So triangle MAH is congruent to triangle CAR by side, angle, side is congruent to side, angle, side. Okay. If you need to, go back and look it over again. And don't forget, we changed the second piece of given to A is the midpoint of MC. Okay. Here we have B is the midpoint of AC, which makes absolutely no sense. So I am going to go back and change that. So this should say W is the midpoint of NR, and YW is perpendicular to NR. And now we'll go play for mistake that your professor makes, because he always makes daily dumb mistakes. He cannot avoid it for the life of him, which is why he never got 100. And it cost me years, well, 100 on the Regents. I got lots of them in regular class tests. It cost me years of therapy. Drove me crazy. But I'm over it now, as you can tell. All right. W is the midpoint of NR. That's what we see on the bottom here. And YW is perpendicular to NR. So get started, use the two pieces of the given, and then I'm going to bring it around and do some other stuff with it. But for now, let's use that given up. Okay, and if you want to race ahead and go all the way to the point where you prove the triangle's congruent, do that. This next thing about angle N and angle R, that you're not ready for yet. You're going to have to wait for that. Okay, so what do we got here? First, midpoint. W is the midpoint of NR, so NW, the left-hand half, is congruent to the right-hand half, RW. A midpoint divides it into two congruent segments. Notice, word in the given is midpoint, word in the reason is midpoint. Word up, man. Next up, step 3, I see perpendicular. Oh, I have to mark it, which I did. I see perpendicular. What kind of things are made by perpendicular lines? Right angles. Very good. There are my right angles, angles 1 and 2. So, step 3, angle 1 is congruent to angle 2 by perpendicular lines form congruent right angles. Okay, so I've got a side, I've got an angle. I want to bring your focus now down to where it says prove. It says prove the triangle's congruent, which we will do in a minute and finish up. It's real straightforward. And then it says prove angle N is congruent to angle R, and that is very strange. That we haven't dealt with yet. So step by step, let's get the triangles congruent and then look at angle N congruent to angle R. So if you're confused by that, don't let it bother you. Okay, next up, I've used up all the given, so I don't need to look at the given anymore. Now I allow myself to look at the diagram, and I'm looking for something that catches my eye in the diagram. I don't see the letter X, so I'm forgetting vertical angles. I don't see sets of linear pairs. That's out of the question. But I do see a side that's shared by both triangles. And it can happen with a side shared by both sides or an angle. Bottom line is, YW is congruent to YW. This says BD. I can't believe it. That's supposed to say YW. That's a really weird looking YW right there. Okay, it's really strange looking, but that says YW. So YW is congruent to YW by reflexive. And I'll put an X in the diagram right there. And then, oh, good Lord. All right, so let's just take this brief commercial interruption. Rather than play the song of Jeopardy, let's talk about the strategy that we always use every time we do one of these proofs. We always look at the given. We use every single piece of the given. And then when we are done with the given, we take a good hard look at the okay, let's get all of this in here. It's all corrected now, so that looks good. See, I have YW running right down the middle, and I have the angles correctly identified. And the triangles are congruent by SAS, and you can see that from the diagram, right? The X is one side, the angle, the right angles, and then the other side here. What's this angle N congruent to angle R stuff? So what I want to do is remind you that way back in the beginning of the year, beginning of this unit, when we started back on Monday, we said that you would think to prove two triangles are congruent, you'd have to show all 6 parts, namely that the 3 sides were all congruent to each other and the 3 angles. And we said, no, it's not that complicated. You can just do side, angle, side. You can just do angle, side, 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 or angle, angle, side. They all work. The problem is this. Once you get the triangles congruent, then all the corresponding parts are going to match up. So once I prove these 2 triangles are congruent, I can say that this piece from Y to N, well, that's going to be the same size as the piece from Y to R, because they are corresponding parts. Angle R is going to be congruent to angle N, because they are corresponding parts. The angles up top here in the vertex, where it's split into 2 equal angles, angle NYW and angle RYW, those are congruent angles because they are corresponding parts. So angle N will be congruent to angle R. And you might want to write, well, they correspond. They match up. If the whole triangles are congruent, then the pieces have to be congruent. And for that, we use this expression CPC-TC. What does CPC-TC stand for? The corresponding parts of congruent triangles are congruent. CPC-TC, the corresponding parts of congruent triangles are congruent. Now here's the thing about CPC-TC. You can never, am I crystal clear about that word? Never use CPC-TC until the step after you've proven the triangle's congruent. So you see in step 5, I proved the triangle's congruent. Then I can prove the parts in step 6 because it says the corresponding parts of the congruent triangles. So if you try to put CPC-TC before you've proven the triangle's congruent, it makes absolutely no sense. It's only once the triangles are proven congruent that you can say the parts are congruent. Okay, so those are 2 proofs done. We'll do some more in a couple of seconds.